Hello and welcome to the webinar on milk fatty acids in organic and grass-fed dairy production by Elle Andreen of the USDA Agriculture Research Service. I'm your host, Alice Formiga of eOrganic. For the past 10 years, eOrganic has published articles, videos, and webinars about organic farming and research, and you can find all of them on our new website at eorganic.org and on the eOrganic YouTube channel. So today, I'm very pleased to welcome Elle Andreen. She is a support scientist at the USDA Agriculture Research Service's Pasture Systems and Watershed Management Research Unit in University Park, Pennsylvania, and she works in grazing dairy research. Elle is going to talk about how the growing interest in milk fatty acids is relevant to organic and grass-fed dairy producers and dairy industry personnel. So with that, I'm going to hand over the screen controls to you, Elle.
Thank you, Alice. Thanks for the introduction. Welcome, everybody. Good morning or good afternoon to you, depending on where you are. Thank you for tuning in today. It looks like we have a really good turnout. So thanks for taking the time out of your day to join us or to watch the recording at a later date. It's good to see that you're all excited to learn about fatty acids. So as Alice said, my name is Elle Andreen. I work for the ARS, which is the Agricultural Research Service. If you're not familiar with the ARS, that is the USDA's research agency. We have locations all over the United States. My location is located on the Penn State University campus in University Park, PA. So I work now in my job in pasture-based dairy production. My background or my education, I have my bachelor's in animal science from Michigan State, and I got my master's in animal science from Penn State. I worked with Dr. Kevin Harvatine. He's a pretty well-known researcher in fatty acids in dairy nutrition, so I have a good amount of experience with fatty acids from getting my master's in his lab, so that's why I chose this topic to discuss today. So before we get started, I just want to make it clear that I'm going to be discussing specifically the dairy cow side of fatty acids. In terms of beef, a lot of the nutritional and the biological concepts will be the same, but in terms of human nutrition, we are hopefully going to be having an upcoming webinar about fatty acids in human nutrition. That's going to be given by Dr. Yana Croft from UVM. So if you could save your more human-focused questions for that presentation, she'll be able to answer those a lot better than I would. So to go over what we'll talk about today, we'll start with what fatty acids are and how we measure them. We'll talk about how fatty acids are metabolized into milk fat. We'll look at which fatty acids are of interest specifically in organic and grass-fed production and why. We'll look at what the research says about fatty acids in organic and grass-fed compared to conventional milk, and we'll also discuss some of the management factors that can influence milk content of the desirable fatty acids. We'll finish up with why all of this matters to consumers and to dairy farmers, and we'll end with our question and discussion session. So to kind of start with the basics, I want to talk about what fatty acids are. So they are basically the building blocks of lipids. So the most common form that you'll find fatty acids in would be this triglyceride. So this is a glycerol backbone with 3 fatty acids attached. So fatty acids have 2 important factors that determine their physical characteristics and their impacts on human or animal health, and those would be the chain length and the saturation. So for chain length, the fatty acids that we'll be talking about in detail today would be the long chain fatty acids. So those would be those with 18 or more carbons in the carbon chain. And then also for saturation, that is the number and position of double bonds in the carbon chain of the fatty acid. So steric here on the left at the top would be fully saturated, has no double bonds. Monounsaturated has a single double bond, and then polyunsaturated has 2 or more double bonds. Another common term that you might have heard of with fats would be trans and cis fatty acids. So those refer to the position of hydrogens around a double bond in this carbon chain. I wanted to point out that both of these do occur in nature, but you've probably heard of trans fats. And what you've probably heard about there would be the artificially hydrogenated trans fats. So those are what are really bad for you. So milk does have both trans and cis fats, but they are not biologically the same as these that you get in your packaged artificial foods. So there are a very diverse number of fatty acids in cow's milk. There's actually over 400, but we only quantify about 40 or 50 most of the time in dairy research, and those will be between 2 to 28 carbons in length. We hear a lot about saturated fat in dairy, but it's actually only about 60 to 70% saturated. It's not 100%. There is a portion that is unsaturated. So for measuring the amounts of individual fatty acids in milk, the gold standard there would be something called gas chromatography, or GC. So GC analysis works really well, but it's pretty expensive and specialized process. So I wanted to share with you a newer technique that's based on MIR spectroscopy. This has been largely pioneered by Dr. Dave Barbano up at Cornell University in partnership with the Miner Institute up there. This technology is similar to what's used at DHA laboratories for milk component and for forage testing, and it is faster, easier, and less expensive than GC analysis, which is great. However, it's not currently able to identify individual fatty acids. They're able to identify, for example, the proportion of saturated to unsaturated and some other specific groupings, but we still have a little bit of a ways to go before we can get the individual long-chain fatty acids. But that is an exciting area where work is going on. So moving on to the cow herself for fatty acid metabolism. I'm sure some of you are already familiar with what I'm going to briefly go over, but I like to sort of start from the beginning so that we're all on the same page. So the cow has two sources of fatty acids she can use to make milk. It's primarily from her feed, but if her feed's not meeting her needs, she also has her body fat stores. But predominantly the lipids are going to come from her feed. So her consumed feed enters her rumen, where the fats or the triglycerides are going to be hydrolyzed, and that will release free fatty acids. They're not attached to glycerol or any kind of backbone anymore. So a small portion of those will exit directly into the lower tract and will enter circulation, but predominantly they'll undergo something called biohydrogenation, where they will become saturated, and that is why we have a lot of saturated fat in meat and dairy products. So those will also enter circulation along with the body fat store reserves that we might be using if she's in negative energy balance. All of those will enter circulation and they'll be partitioned to the mammary gland for milk fat synthesis. Now, when they enter the mammary gland, if they are less than 16 carbons, so this group on the left side of this graph, those would be referred to as de novo fatty acids, and these can be modified or repackaged into new fatty acids. Whereas if they are longer than 16 carbon, the right side of this graph, those are called the preformed fatty acids, and they are incorporated essentially unchanged into milk fat. So the preformed fatty acids are much more reflective of the diet. So milk fat profile can definitely be influenced by the composition of the diet. So because of that, I wanted to take a couple minutes and talk about this table, which has 5 of the most common fatty acids in some different feeds. So we have palmitic, stearic, oleic, and then these two at the end here that I want to focus on specifically. In orange, we have linoleic acid. So linoleic acid is in high proportion in some of our more quote-unquote conventional feeds like corn silage, distillers grain, soybean meal, whereas we have relatively less of it in our more pasture and forage-based feeds. For alpha-linolenic acid, ALA here in blue, you can see it's pretty much the opposite. We have a lot larger proportion in our pasture-based feeds and much less in our conventional feeds. So these two fatty acids, LA and ALA, are actually quite relevant in human health. They are the two essential fatty acids, so that means that we cannot synthesize them in our bodies, and so we need to consume them from our diet. And you've probably heard them referred to as omega-6 and omega-3s. That's the type of fatty acid that each of these are. So linoleic is the most common omega-6. It's found in vegetable oils, grains, and ruminant meat or milk products. And then the omega-3s are alpha-linolenic acid, as I said, ALA. That's found in nuts, seeds, and plant products. And then there are two other omega-3s we'll talk about, and those would be EPA and DHA. And both of those are found in aquatic sources, especially oily fish. So talking about the omega-6s and the omega-3s, I just want to make it clear that both omega-3 and omega-6s are very important fatty acids for human health. So for EPA and DHA, they're not technically essential because we can synthesize them in our body, but our conversion efficiency from ALA to these longer chain omega-3s is very poor. So that's why we're recommended to consume them in our diet. And it's more that we just hear more, in the media or from health providers about omega-3s, because in our Western diets, we usually don't have a problem meeting or exceeding the requirements for omega-6 because we eat a lot of the vegetable oils, the grains, and ruminant products that are rich in omega-6. But the issue that we run into with omega-6 and omega-3 is that the ratio of 6 to 3 should be more like 4 to 1, or lower, and whereas most Western diets are more like 10 to 1. So it's not that omega-6, isn't good for you, it's just that our ratio is a little bit skewed. So we're often advised to eat more omega-3s in order to have a better ratio. So the point of discussing all of this, kind of what we're getting to, is that as I showed you, the pasture-based ingredients have a lot more ALA, this omega-3, which is also a precursor for EPA and DHA formation in the rumen and the mammary gland. So our question is, with all this ALA, could pasture-based dairy products help us get more omega-3s? So in addition to omega-3s, the other type of fatty acid that we'll be talking about today is CLA. So that's conjugated linoleic acid. That's found in dairy and meat products. The most common form in ruminant products is called cis-9 trans-11 CLA, or ruminanic acid. And that has been shown, I believe, for a couple decades to be anti-carcinogenic. So the other nice thing about CLA is that it's relatively stable throughout the processing and manufacturing processes. I did include this table here on the right from Penn State Extension that's showing the total CLA amount in several different types of foods. I do believe that these are conventional foods, not necessarily grass-fed dairy or beef. And then I also just want to note really quick that this is total CLA per grams of fat. It's not CLA per serving of each of these foods. But one interesting thing that we do know about CLA is that we've observed variable content of it in milk. So that basically indicates that the concentration of CLA could be modified by management. And one major factor that researchers have found is that the consumption of pasture can really modify CLA. So it's been observed to increase up to 2 times as much when cows are switched from a conventional to a pasture-based diet. So before we go on and get into the research around these fatty acids, I just want to make the point quickly that all milk, regardless of its production method, has healthy fats and other nutrients. And stepping back, looking at milk in general, scientists are starting to recognize that milk and milk fat is healthier than we've previously thought. We've been advised for a long time to avoid full-fat dairy, but it's starting to come out that that might not be true. So there have been multiple large studies and reviews of previous research that have been published in major publications, things like the American Journal of Clinical Nutrition and the European Journal of Nutrition, stating that reduced or full-fat dairy consumption is not associated with increased cardiovascular or other health risks. So on top of the already increased interest in just the general healthiness of milk, we have this specific interest in the organic and grass-fed milk because of its potentially different fatty acid content. So in our introduction, we've pretty much gone through the biology behind why we might see different fatty acids in our pasture-based milk. So now we're going to look at what the actual real-world research says. How does this play out on real farms? So the first study that I want to go over with you is a meta-analysis. So that's basically taking data from 69 different publications. There are 260 treatment groups within those publications, and 19 of those are from feeding fresh pasture. So this was basically comparing a pasture feeding treatment to a control conventional feeding treatment and all of these different supplements that could increase CLA. So what they found here was almost a 2 times greater concentration of CLA in the pasture-based treatment versus the control treatment. And they saw a numerically higher amount in the pasture treatment, but it wasn't statistically different from all of these different supplements aside from the fish and vegetable oil treatment. But what that means essentially is that you can achieve the same CLA increase by feeding pasture as you can with all of these various extra supplements. And then in terms of total CLA produced per day, the pasture treatment is, again, it's numerically higher, but it's not statistically different from the control, but that is probably due to a lower milk yield and a little bit lower milk fat yield. So just to summarize their findings for you, they saw that total CLA production was almost 2 times higher for pastured cows. And when I say CLA production, I mean the concentration in milk. But then in terms of the total CLA production per cow per day, that could be limited just because of the lower milk yield that you can get with feeding a larger proportion of pasture or forage. So something else really important to consider when we're talking about CLA is that it can be really heavily influenced by seasonal variation. So this graph here on the right is from the same study that I showed you in the previous slide, and it's showing average CLA concentration in conventional, which is the dark squares, versus organic, which is the light or open squares, over about, I think, a year and a half. So looking at CLA just within the organic group compared from summer to winter, we see about 55% higher concentration in summer versus winter, whereas in conventional, we only have about a 12% higher concentration in summer versus winter. And then comparing organic to conventional, in the summertime, we see that organic has about 42% higher CLA in summer, but then in the winter months here on the far side of the graph, there's not really any difference from the conventional milk. So we do see similar seasonal patterns, but a little bit less variability in, for the omega-3 fatty acids. And something else I wanted to note with the seasonality of CLA, because this is combining data from multiple studies in multiple regions, the timing of cows going on and off pasture is not going to be the same as if you were using data from, a single herd, but you can kind of see it illustrated in this graph where looking from somewhere like March to July, you see it takes a couple months for CLA or a couple weeks for CLA to reach its peak concentration on pasture, whereas when you're looking over in the fall, it can drop off very quickly. So in work that's been done in a single herd, it was shown that it took over 3 weeks after turnout for CLA to reach its peak value, but then I believe 3 or 4 days once they were taken off pasture for it to return to the previous level prior to going out. So we've seen our meta-analysis, and that's with data mostly from research trials rather than actual commercial farm data. So the next study that I wanted to show you is with genuine retail milk. It's not milk from research farms and research studies. So this study collected milk from 14 different processors in all over the United States. They took 1 milk sample a month across 18 months, and 220 of those were organic and 164 were conventional. So I pulled out just sort of the highlights of what they found for you. This is the averages across 1 year. So you can see they saw about 60% greater concentration of ALA in organic. So this column is our percent greater in organic. And then about 20% greater EPA and CLA in organic. This is in pretty good agreement with yet another meta-analysis that was conducted on this. You can see here for ALA, EPA, and CLA, they saw pretty similar results. But something that I just wanted to point out within these two, just looking at these coefficients of variation here in this orange square, those are pretty high. So what that is indicating is that there's variability, especially in EPA and CLA, in their content over the year. So that again is related to that seasonal variation that we just discussed in the last slide. So they only saw, as you can see, about a 20% difference there, but that is averaged over the entire year. So during the summer, you might have much higher CLA and organic, whereas in the winter, you might have no difference. So when you average that out over an entire year, that's where you start to get a little bit more moderate of a response. So before we go on, we have so far pretty well established with scientific evidence that the pasture-based milks do have higher amounts of these beneficial fatty acids. But I just want to put their contribution to our daily intake of omega-3 and CLA in perspective before we go on. So I did just some quick calculations here. Assuming that a person consumed 40 grams of dairy fat a day, which is a little bit high, but not ridiculous. That's something like 1 to 2 servings with a meal or with every meal. And I used the increases from conventional to organic from the research studies that we've seen so far. And I tried to use values that were based on feeding pasture only, not supplementing cows with anything particular to specifically increase these fatty acids. So for CLA, if CLA increased from 0.6 to 1.1% of milk fat, your total intake from dairy, assuming you were eating 40 grams of fat a day, would increase by about 0.2 grams. So there's not really a standard recommendation for CL intake that I could find. It's still kind of a new area, but from what I've seen in clinical trials in humans, they've had doses ranging from 1 to 8 grams of CLA per day. So, you know, less than half a gram is not necessarily a huge amount in that context. But for omega-3s, however, there is an NIH recommendation. There are not recommendations for ALA, EPA, and DHA individually. It's just your total omega-3 should sum to between 1 to 1.5 grams a day. So for ALA, if ALA increased from 0.5 to 0.8% of milk fat, your total intake from dairy would increase by about 0.12 grams to about 0.032 grams total. So that would account for about 20 to 30% of your omega-3 requirement, your daily requirement, which is not bad. It's not huge, you know, it's not 90%, but it is something. But then in terms of EPA, if EPA increased from 0.06 to 0.1%, your increase would be about 0.16 grams, or sorry, 0.016 grams per day, and that's only going to count for less than 5% of your requirement. So it's really not contributing quite as much. So considering these both together, pasture-based milk, depending on how much of each of these fatty acids are present, could account for about 23 to 34% of your daily omega-3 requirements, which is about 10% more compared to conventional. So there is a difference, and it is higher, but I just want to make it clear that it's not a huge difference. So you hear 200% higher, and you think, wow, that's so much. But because of the proportion of these fatty acids being so low in milk, a 200% change might not add up to as much as you would think. Sorry if you hear some intermittent pausings. I have a hard time talking for 45 minutes without drinking some water. So So given that CLA and the omega-3s are higher but not drastically higher in organic and grass-fed milk, what can we do to further increase these if they are desirable for human health? So there's a couple challenges and also a couple strategies for maximizing these. Just to start with the kind of barriers, the first issue is the rumen biohydrogenation that I talked about in the beginning of the presentation. So fatty acids are extensively modified by the microbes in the rumen. This is almost impossible to control. So you can influence the fatty acid profile by changing the diet, but you'll always kind of have to deal with the middleman of the rumen microbes, which are going to modify whatever you're feeding to the cow. Secondly, there is low synthesis of EPA and DHA in the cow, similar to the human. So even though with a pasture-based diet, we would have this big pool of ALA from the forages and pasture, only about 0.2% of that is converted to EPA, and even less of that is converted to DHA. So the conversion is just biologically very limited. And then lastly, when you think about that the cow herself struggles to make EPA and DHA, that means that we have a low transfer of these into milk. So whatever she's able to synthesize in her own body is not well taken up by the mammary gland. And that's probably because it needs to be spared for her own necessary bodily functions. But there are some strategies that we can use to increase CLA and omega-3s in milk. So I will quickly go over those in this slide. So one of the easiest methods would, for at least for the organic and grass-fed, would be increasing your pasture and forage intake. So for organic and grass-fed, this is basically like a built-in method. And those systems have a clear advantage here compared to the conventional systems that would have a lot harder time changing their forage or pasture feeding. So the only issue with that, though, is kind of like we mentioned with the CLA production, it can reduce milk fat and milk fat yield, so it could reduce the total production of healthy fatty acids, but your concentration of them in milk is still likely to be higher. There are some supplements that you can feed. I do realize that not all of these would be necessarily appropriate for a organic or grass-fed system, but I did want to include them. So flaxseed is one that's been pretty well studied. It's often fed as an extruded or encapsulated form that can help protect both the unsaturated fat in the flax and also protect from getting a decrease in milk fat. You do still often see a decline in milk fat, and that's probably due to the unsaturated fatty acids. You're increasing basically your load of unsaturated fat in the rumen, and that can lead to things like milk fat depression. It's also important to think about that the ALA content in the flax can vary by season and strain. It may not always be consistent. Flax feeding, as far as I'm aware, hasn't been super well assessed in pasture-based conditions. There's been a lot more work done with conventional housing. And then lastly, it is expensive. It is an additional cost, and you have to think about how you determine your benefits. So people feed flax not just for changing the milk fatty acid profile. I believe it also has some reproductive and immune system benefits, but you have to think about how you quantify that and how you quantify your returns. So if you're thinking about using flax for milk fatty acids, you have to think about how would you actually quantify, is this changing my milk fatty acid profile, and then am I getting paid for that at all? There is also the fish and unsaturated plant oils. These are especially effective in increasing EPA and DHA, but they do have some issues with storage and rancidity. They can be unpalatable, and they can cause pretty severe milk fat depression if they're fed incorrectly. And then similar to the flax, the actual fatty acid content can vary by species. And these also the same thing. They are expensive. You have to think about the cost versus the benefits. And at least in my opinion, in terms of the fish oil, if we're feeding it to try and increase EPA and DHA, we're probably just better off eating the fish ourselves because it is something that we can digest. And it will have a higher concentration of those fatty acids than if we fed it to a cow. So I included genetics here as well because I just think this is something interesting to think about. So the CLA content of milk has been shown to be variable between animals that are under similar management. So that basically means that there's some trait or character about that animal that is changing their CLA content, which means that there is an opportunity for selection for animals that produce more milk CLA. So there have been some breed differences shown. From what I've seen, Holsteins had greater CLA in 3 studies that were feeding conventional diets and 1 on pasture, and I believe they were compared to Jerseys and to Brown Swiss, but the difference in the milk CLA content was not as drastic as it would be if you were comparing something like milk fat yield or milk yield between a Holstein and Jersey. So for the heritability of milk CLA, it's been found to be low to moderately heritable, but there's a couple issues with selecting for it genetically. So it's negatively genetically correlated with milk fat production. So most farms probably will be selecting for milk fat production given how valuable a component it is in a lot of pricing schemes. So that would make selecting for CLA content difficult. And then the other issue is that without access to testing for milk CLA, it would be difficult to know, which animals are producing best, which can I select for. But given our interest in CLA, this is just something interesting to think about, might be becoming more relevant in the future. Okay, so I've thrown a lot of biology and a lot of numbers at you, so I just want to step back and try to put this in perspective. And we want to recognize that while the public and consumers probably don't understand, the finer details about fatty acids that I went through today, they are aware of the differences in fatty acid content of pasture-based milk compared to conventional. So we have, major popular publications, things like Parents Magazine, NPR, Reuters, Good Housekeeping, these big publications touting the benefits of pasture-based milk. And I did include this Horizon Organic DHA milk here. I just think it's a little bit funny. DHA, as I talked about in this presentation, is produced at very, very low concentrations, even in grass-fed milk. So I think it's funny that their DHA is actually from algal oil, which is a perfectly fine source of DHA, but I would be pretty surprised if every consumer buying this was 100% aware that it was not being made by the cow. But all of that aside, there is public awareness of these fatty acid differences, and at the end of the day, they help support the demand for organic and grass-fed, and ultimately the price of these products. So that consumer awareness is important to us because that demand could help drive how cooperatives value the fatty acids in pasture-based milk. So I pulled these figures in the bottom right here directly from the Organic Valley website. And I think that these make it pretty clear that Organic Valley and the other co-ops do value the fatty acid content of their organic and grass-fed milk. So now whether the content is always, 147 or 125% higher than conventional is kind of hard to know. But nonetheless, this is clearly a marketing strategy that works, and consumers have definitely responded to it. But like I mentioned before, there is variation in the content of fatty acids in grass-fed and organic milk, especially in CLA. So I just wanted to kind of put the question out there, could cooperatives potentially start putting a premium on milk fatty acid content? If they value it so much and they're very good at marketing it, maybe they should be paying producers for it specifically if they're doing a good job producing it. So there's just a couple things to think about with that possibility. First of all, we would need to have reliable and inexpensive testing for the individual fatty acids that they're interested in. You'd have to think about seasonal variation. So I showed you those graphs of the changes of at least CLA over the year. So how do producers and cooperatives cope with the natural seasonal variation of these fatty acids? If you're advertising that you have, this much and this much higher CLA or omega-3, how do you ensure that over the entire year? And then lastly, we have to think about the cost of supplementation or other strategies. Is the cost of supplements or of different management really worth the additional value added to the milk or the value paid to the producer? So as far as I'm aware, cooperatives right now are not looking at fatty acid content from individual farms, but it's certainly just something to think about given how much they appear to value it. So that is pretty much all I have for you today. I just have some conclusions and takeaways here. So as we saw, there have been multiple peer-reviewed scientific publications that have determined that the pasture-based milk contains higher concentration of some beneficial fatty acids. So for ALA, that would be about 40 to 60%, CLA up to 2 times, but can be variable, and for EPA, about 30 to 40%. However, we do have to keep in mind that the impact on human health depends on the specific fatty acid content of that milk and how much milk fat is actually consumed. So the higher fatty acid content of some of our desirable fatty acids appears to be largely due to the dietary proportion of pasture and forage. And this is a natural and low-cost advantage for the organic and grass-fed dairy systems in comparison to conventional. There are some management factors that can alter the content of milk fatty acids, but they might not be realistic to implement, especially for the grass-fed and organic systems. So those include things like biology, the ruminal biohydrogenation, and poor transfer into milk, the issue of quantification, that right now it's pretty expensive, but could be potentially improved in the future. And lastly, just thinking about our costs. If we're supplementing to try to improve these fatty acids, are we really thinking about whether that's going to yield additional returns? So lastly, all of that notwithstanding, it is true that the fatty acids in pasture-based milk do contribute to increased demand for, and ultimately the price for, at the end of the day, organic and grass-fed dairy products. So that is the end of my formal presentation. The webinar that you saw today was produced as part of a USDA NIFA Organic Research and Education Initiative grant, or OREI grant. That is titled Advancing Grass-Fed Dairy, a Whole Systems Approach to Enhancing Productivity, Quality, and Farm Viability in the U.S. So the PI on that grant is Dr. Heather Darby. She is at the University of Vermont. So this grant in general is a collaboration between University of Vermont, USDA ARS, and University of New Hampshire. So that is all that I have. Thank you guys for tuning in, and we can go ahead and start the question session. Alice, if you're ready.
Yes, I'm ready. Thank you very much. We are going to start our question and answer period. So let's see. The first question that came in was, do we have, are there any studies that you know of on the fatty acids of unpasteurized milk?
So I believe it is the second meta-analysis that I showed. I would have to look back for the authors, but I think there has been some work in looking at the fatty acid profile in raw versus pasteurized versus ultra pasteurized. I couldn't tell you off the top of my head. I mostly tried to focus on, or just organic or grass-fed versus conventional for this, but I do know that the work is out there. I can say I'm pretty sure, at least for CLA, that it was not influenced by the level of pasteurization, but I'm not sure if the same would be true for omega-3s or maybe some other fatty acids.
Okay. Let's see. Yeah, here's another question about pasteurization here. Let's see. Does ultra-pasteurized milk versus pasteurized milk versus raw milk change the fatty acid profile or the fatty acid amount? Let's see if we can maybe go back. Elle, do you want to just scroll back to that slide there? You ought to still have control there.
Yes.
And
Let's
maybe you can
see.
pull up what that meta-analysis was if people want to look that up, because maybe they can find some information there. Which one was
So
that?
I believe that was this Benbrook et al. In 2013, would have been in Public Library of Science 1. I
Okay.
believe that is the one that I looked at. I think that some of these some of these processors had at least ultra pasteurized versus pasteurized. I don't think that they included raw milk in this study, but I am pretty sure that there would be some information out there about fatty acid profile in raw milk versus pasteurized.
Okay, thanks. And this person thinks that raw milk tastes better, so, and that's his own research. So let's see. Do you have any numbers comparing the CLAs in grass-fed cow milk rather compared to organic sheep milk? Do you have any information on sheep milk?
I do not. Actually, in this same slide, this other meta-analysis, the one on the right side here, I think that would be Srednica-Tober. That's in the British Journal of Nutrition. That is a really big, complicated meta-analysis. They did include, I believe, sheep and buffalo milk in there. I did not read through that while I was preparing for this presentation, but I do think that the information is out there.
Okay, and how do fatty acids behave on cheese? Does that cheese making process affect the fatty acid content?
That's another good question. Again, I can tell you that for CLA, there haven't been, there have been some studies done. How is the CLA content preserved throughout the processing processes, for lack of a better term? And I do know that CLA is pretty well preserved, but again, I'm sorry, I don't know exactly for the omega-3s. Like I said, I knew that this would kind of come up, that I am, much more familiar with the dairy cow side. I'm not as well versed beyond the end of the cow, basically.
Okay, let's see. Hemp seed meal has a high level of omega-3s. Do you know of anyone who is doing research in this area?
That's a very good question. I think hemp is a really popular area right now. I don't know if anyone is doing specific research with it. Oh, my slides are
Oh, I'm
advancing.
just advancing them forward so people
Oh, I
can
see.
find the link to the archive.
I see.
Sorry.
Yeah, so I'm not sure exactly if anybody is. I would say it's likely given how much of an interest that hemp has had in recent years. I think there are some legal issues with hemp. I'm not sure if it's legal to feed to animals right now. I could be wrong on that, so feel free to correct me if anybody would know. But that is a very good question.
Okay, yeah, if anybody has comments on that, feel free to type them into the chat box, and then you can share with the information with everyone. Where it says two, you can share the information with all the panelists and the attendees. So let's see, do you have any comments about using palm products recommended to increase milk fat and its effect on the milk fatty acid profile?
So palm products are some of the most popular fat supplements with palmitic acid. There's a huge amount of research out there about using palm fat supplements to increase milk fat. I mean, they certainly do. That's pretty beyond the scope of what we're talking about today, unless your question is specifically in organic systems. I'm not sure of what organic palm supplements would be out there. I mean, obviously you could feed oil seeds, but I'm not sure if the, commercial palmitic steric mixtures that are available, if any of those are suitable for organic production. But palm products in and of themselves do have a very major effect on milk fatty acid profile. And actually, Dr. Adam Locke at Michigan State has done a lot of work in that area, and so has Dr. Harvatine at Penn State.
Okay, can you clarify the differences between organic and pasture-based systems? Because this person had the impression that you implied that they were similar, or they were kind of the same?
So I did kind of consider that when I was making the presentation. The grant that is that I'm doing this presentation for is specifically for grass-fed. So that would be 100% grass-fed, so no grain feeding whatsoever. All dry matter intake from pasture or conserved forages. So but the issue there is that there's not a whole lot of research on grass-fed in terms of fatty acid profile. So I decided to include organic in there as well. And I didn't want to constantly be saying organic and grass-fed. So I did substitute pasture-based systems in there quite frequently. So whenever I'm saying pasture-based, that is sort of a spectrum from a low input pasture system to organic farming. So I'm not trying to mince words there. I'm just the point is basically that with our increased pasture and forage intake, which you usually see in organic or grass-fed farms, that's where we see the changes in fatty acids. So I hope that answered your question reasonably well.
Okay, hopefully it did. And if you have any further questions, definitely feel free to type them in because we still have plenty of time. We have a comment here that yes, there are organic palm products available. Thank you for that. Okay, next question. This person is curious if you know if the feed in the winter roughly the same for the organic and conventional. It seems like there might still be an advantage for feeding dry hay versus TMR.
So I would assume, again, this is going to depend on the specific farm. If you're looking at organic or 100% grass-fed, I would guess that looking at sort of a classic organic farm where they might be feeding some organic corn silage compared to a conventional farm where they would be feeding a large amount of corn silage, but also, other conserved forages. I don't want to say that they're roughly the same, but organic or grass-fed, they would be more similar to conventional in winter than compared to summer, obviously. The other thing where we're talking about the seasonality, you also have to think about, that the graphs that we looked at were composites from many different farms. So that's, an average across many locations, many different herds, many different diets. So, looking at an individual farm, there probably is still an advantage, like you say, for feeding dry hay and conserve forages, on a organic or a grass-fed operation versus feeding a conventional TMR on a more conventional system in terms of the fatty acid content.
Okay. Is there research that indicates which, if any, breeds of dairy cattle produce the highest levels of beneficial fatty acid? And is there any correlation between beneficial fatty acids and the level of A1 or A2 proteins?
So that is a good question. I did talk a little bit about breed in the presentation. That's not something that I spent a ton of time researching for this. In my sort of flyover of the literature, it seemed like there was a little bit of an advantage in Holsteins, but I'm not sure if it's something that's really been super extensively evaluated. And from what I did see, it didn't seem Holsteins make twice as much CLA or anything that drastic. And then in terms of the beneficial fatty acids or the level of A2 and A1 proteins, I haven't seen any specific work on that. That doesn't mean by any means that it's not out there. But I would be interested to know, just thinking about the biology behind it, where we see the difference in the beneficial fatty acids would be mainly through the diet, is the pasture and forage intake. Whereas for the A1 and the A2 proteins, as far as I'm aware, that's really more of a genetic component. I'm not sure if that's something that you can influence through anything other than breeding. So there might be a correlation, but like I said, the biology is a little bit divergent.
Okay, we have another question about whether fatty acids persist when they're processed into butter and cheese.
I basically, I pretty much have the same answer that I did to our previous question. I'm fairly sure for CLA the answer is yes, it persists, but again, for the omega-3s and some of the other ones, I'm not 100% sure.
Okay. Let's see, can you offer some extra insight on de novo numbers and how herd nutritionists can use this information? St. Albans in Vermont does offer this on herd readouts.
So de novos. I feel like anytime anybody talks about fatty acids, somebody will bring up de novos. So I know I talked about de novo and preformed at the top of the presentation, but that was really more just to emphasize that the preformed portion of the milk fatty acid profile is pretty heavily influenced by diet, and to kind of make the connection between diet and the milk fatty acid profile. I don't really want to get too into dissecting de novo numbers for you. I will direct you toward some of the work that's been done by Dr. Heather Dan at the Minor Institute in partnership with Dr. Barbano. They've done a lot of a lot of work using bulk tank de novo values on herds, especially up in New York. So I don't know if that's exactly relevant to our discussion today, but I know they have a lot of materials discussing de novo numbers and how they can be useful.
Okay. Let's see, are there specific forages that could be incorporated into pastures that are known to be high in CLA or could be synthesized into higher CLA?
That is a very good question. I'm not sure if the actual forage content of CLA is different. So when we think about omega-3s versus CLA, for omega-3, you're actually increasing the cow's consumption of omega-3. You have more ALA in your pastures and forages compared to corn silage and whatnot. But as for CLA, from my knowledge, how the pasture-based feeding results in the increased CLA is more through a shift in rumen biohydrogenation, and that's part of why it takes so long for CLA content to become maximized or reach its peak during the summer outdoor period, because the rumen microbiome needs time to adapt. I do think that there is a precursor factor where forages and pastures contain some precursors to CLA, but yeah, I'm not sure if there are actual, cis9 trans 11 CLA in forage products. I don't think there are. I think that's something that you can only get from ruminant products.
Oh yeah, one last question and then we'll end. Okay, what types of grasses or legumes will have a greater impact on fatty acids?
So I can tell you at least one that I have read a little bit about could have a greater impact on fatty acids, and that would be red clover. I believe that's because of an enzyme that the red clover contains, and I think that can help boost, I believe it's the omega-3s. So red clover is really the only one that I can think of off the top of my head.
Great. Okay, well, thank you everyone for all these great questions. And I've got the link here to the recording. And if you'd like to learn about any of our many upcoming dairy webinars, which we're planning them, they're in the works this winter, and we're going to be announcing them as soon as possible. Please subscribe to our newsletter at eOrganic.info, and then you'll get notifications. So thank you so much, Elle, for giving this presentation. We have another fatty acid webinar that we're going to be planning on March 25th, and we look forward to more webinars from your project team.
Thank you, Alice. Thank you everyone for tuning in. My email address is at the end of the slides. If you have an additional question that you didn't get a chance, or you think of something, or I just didn't do a good enough job answering your question and you want more information, please don't hesitate to email me there and I will definitely get back to you. So thank you again, everybody, for tuning in, and have a good rest of your day.